Morning everyone, thanks for joining us today. My name's David van Kesteren and I'm going to host this webinar along with my colleague Matt Langham, who's sat next to me. We've also got Emma Wilson in the background, who's our ICE coordinator, who some of you may or may not know, and she's going to help us coordinate any questions that you ask as we go through. So we're going to start with a presentation that should last between 15 and 20 minutes, and for the people who've joined the webinar, you're in a listen-only mode, so you won't be able to speak to us, but you can submit any questions you might have at any time just using the question bar at the bottom below the slides. If we pick up any questions as we're going and we're able to answer them as we're going through the material and it fits in the right place, we'll do that. Otherwise, we'll save the questions until the end of the presentation, where we'll have a question and answer session, where again you can still submit more questions, or we'll deal with the ones that have come in as we go through. After that, once we've wrapped up on the call, if you are still interested and want to ask us any more questions, we'll be available through Twitter on @PowerGridNews and #AskDVK. Also, we've got Emma's contact email address there on this slide if you want to direct email her at all. Okay, so just a bit of history, I suppose, to start with. It's always worth understanding where we came from. Customers have been asking for information on how they can find out where there's spare capacity on our network for quite a while, and as a result of that, back in 2015, we created a snapshot view, which was almost sort of coloured in pencils, of our network, showing where there was spare capacity and where we were really full. And when I say full, that doesn't mean that you can't connect there. It just means that the cost of connection is likely to be very high. So we provided that as a first pass, a bit of a stopgap, and that gave us a bit of a breathing space to go away and try and develop a tool that was a little bit more interactive. So in the spring of 2016, we were able to release our first interactive heat map, which pretty much looked like it looks today, but at that point in time, we hadn't got ourselves into a formal update process, so updates were a little bit sporadic. There were clearly going to be a few glitches here and there that we find out over time, but since the start of this year, we've been able to consistently provide monthly updates to the heat map systems, and we have some dedicated resource, Matt, who's sat to my side, who makes sure that all that data gets done on a regular basis and processed so that we try and give you the best possible picture. So what is the purpose and scope of the heat maps? Well, the purpose of them is to inform you of the network's potential capability to connect large-scale both generation and demand projects. And we've got two sets of heat maps, one for the generation side and one for the demand side. They're aimed really at HV and EHV connections, so that's people connecting at 11 kV on our network or at a higher voltage. Within the data set, it has all of our 132 kV, 66 and 33 kV substations, and all those substations that have 11 kV and 20 kV circuits coming out from them. But it doesn't actually include all the 11 kV circuits themselves. We did have a look at doing something like that, but the vast volume of data associated with those circuits doesn't lend itself to us producing a simple heat map that we can keep up to date. It also, therefore, doesn't include any low voltage network. So people who are wanting to connect very small items, the heat maps aren't particularly beneficial to them. So where do we find our heat maps? Okay, on this slide, I've given you a couple of direct links that will take one to our generation maps and one to our demand maps. However, the easiest and quickest way to find them is just to go into Google and search something like MPG heat map or electricity heat map, and they will pop up right at the beginning. If you miss out the word demand, you'll only get the generation heat maps. So if you're looking for the demand heat maps, make sure you include demand in the search string. If you put demand in the search string, you get both. And on the right hand side there, there's an example of me just Googling it earlier today. Okay, so you've hopefully at that point you've found the way in, and if you were to click on one of those links, this is the page that will pop up. So here we have some disclaimers to really warn people that the heat map data that we're giving you is only indicative. Okay, we can't guarantee you a quotation or that capacity will be available at the time that you apply, but it does give our optimistic view of the amount of generation that could be connected at the different places on our network, or the amount of demand load. That doesn't mean that we can accommodate that all as one connection, because there are other issues associated with large generation projects all in one place, but cumulatively that's the amount of generation that we could connect on the network. Interesting to note on this sheet, it also tells you when it was last updated, so it's indicating on the slide that it was updated in November 2017. So at the bottom of the slide, you simply click the I accept terms and conditions and you're away. When you click on the link, you come up with this screen. So I'm going to take you through now a bit of a guide of how we can use the heat maps, what the functionality is. But just before I dive in there, I'll just point out that at the bottom of the sheet here, you can see a button that says download heat map data. So all the data that I'm going to show you associated with substations is available in a spreadsheet that you can take offline and use yourselves to search through. What you don't get in that spreadsheet is the northings and eastings, the grid locations of the substations. We don't put that in there because from a general site security perspective, putting all our substation locations in one place is considered to be a risk. So it's not that we don't want to share that data with you. It is available in effect on the maps, but we don't make it too easy because of the risk of safety and security for the network. So on the when you first open it, you have this map user guide that pops up in front of you, and just tries to give you a few clues on how to use the heat maps to your advantage. Now, I'm not going to talk through on this thing. What I'm going to do is I'm going to then go onto the heat maps and explain it to you, showing you where the buttons are. So what I will say before I dive in there is the general color coding is red means that when we say low, we mean there's not a lot of capacity left. Okay, so if an area is red or a substation is red, then we're really saying that the probability of connecting anything there cheaply is very low. Whereas if we're green, we're saying that there's plenty of spare capacity in that area and you should be able to connect without having to cause any reinforcement works. And if we're amber, medium, then it means that there is still some capacity left. If you've got a very large project, you're probably not going to fit without any reinforcement. But if you're a smallish project, there's a very good chance that you'll still fit on. Okay, so the first thing to say is once you've clicked off that user guide, this is what you'll see. And you've got a map here with lots of colours on the background and lots of substations highlighted in red, amber or green. And what you're seeing at the moment isn't all of our substations. We split our substations into three categories. And the first category is the one that's black at the top, and I've highlighted it with a little circle. And this is showing all our, what I would call primary substations, where they have circuits coming out of them at 11 kV or 20 kV. And they're the general circuits that go out into the network to feed the masses of our customers, and there's only one transformation level left after that, which is down from 11 kV or 20 kV down to the low voltage that our domestic customers receive. So this shows all those key substations. If we moved up and clicked on the bulk button, then these are the substations that supply all of those primary substations. So these substations have circuits operating at 33 kV and 66 kV going out of them. So clearly there are less of these because these feed out radially to all our primary substations. Some of these substations connect directly into the national transmission network, but a lot of our sites are actually connected via higher voltage network at 132 kV. So if we click on the square button, it will show us on the map all our substations that have 132 kV, 132,000 volt substation and circuits coming out of them. So these are all points where we interact with National Grid and the transmission network. So it's important to recognise that you're not looking at all the substations to start with. And if you're looking at a relatively small project, then you really want to be back on the primary site. So we've got this map in front of us. If you're interested in a particular area, you can type your postcode in the top left corner and it will zoom in on the map to that area. But equally, if you geographically know roughly where you want to be, this is in effect Google Maps. You can move around, navigate, zoom in to try and get a closer look. If you identify the substation that's nearest to where you want to develop, then you can hover over the substation. In this case, I'm hovering over our Malton substation, which is a 66 to 11 kV substation. And when you hover over it, all the colours on the back go away, and you're just left with the area served by this substation. Now, I should point out these are postcode districts, so all it means is that there is at least one customer fed in that postcode district from this substation. It doesn't mean that it feeds the whole of that area. Okay, from a granularity point of view, we have to come up with something that broadly showed where we supply our customers, but couldn't really go into the detail of where every customer's positioned and draw that as a picture. So we can see here that Malton substation feeds quite a reasonable amount of North Yorkshire. And it's coloured up amber, so we're saying there is some capacity here, but if you've got a big project, you're going to struggle. So the colour on the background at this point is important. I should just point out that if I just nip back a slide, the colouring on the background, on the general background, before you click on a substation, we've got a bit of a glitch with that, and it doesn't necessarily show the right colour for the right area. So please take this initial view with a pinch of salt, but once you hover over a substation, that colouring is absolutely correct and gives you a good view. So do make sure that you find a substation locally and hover over it to find out how constrained it is. If you then click on the substation, you get this window pops up, the one that I've highlighted in red. And what it has is a number of features, characteristics of that substation, and there's a big bar there that's in black that says downstream. And if you were to click on the upstream bar, that view would change to the extra one to the right-hand side that I'll talk about in a minute. But I just popped them both on the screen here so you could appreciate that there are two different views, and it's important that you look at both. So when you look at the downstream button, this is trying to give you some clues about how constrained the network is looking outwards from this substation. So it's a 66 to 11 kV substation, so this is looking out into the local 11 kV network, which is where smaller projects will be connecting. So it's telling us about the fault level. Some of these terms are technical terms and therefore may not mean a great deal to a lay person, but if you more technically minded, you would be able to appreciate that the fault level there is not particularly high. So we've given it a green marker. There's also something about voltage. When we connect generation to the network, it generally increases the voltage on the network, and there are limits within which we need to stay. So the lower that number, the more constrained we are on voltage, because for the more technically minded, it's an indication of the number of taps we've got left on our primary substation before we can no longer control the voltage. So as that number gets lower and we've got less taps available to us, so the colour changes. And if that voltage said 1, then it would be a red. We're saying here it's an amber. There is a little bit of capacity left before we run out of voltage, but not a great deal. The next one tells us about how able we are to move power away from this substation. So if the amount of generation within the group exceeded the amount of demand, which can often happen at times of minimum demand, the power needs to flow back up the network to be used elsewhere. and some of our substations are restricted in their capability on this. So in this particular case, it's telling us that the capability of the network for the power to go in the reverse direction is 100%. So we don't have any issues there, and we give it a green. The next one, voltage constraint issue, is really just reflecting in words the voltage number that I pointed out earlier. So it's, again, for the layperson, it's trying to say, look, there might be some capacity, but we're a little bit limited. And then the last one on this screen is physical constraints. So this is used where we maybe have physical difficulty in extending the substation. So if you wanted a connection that was connected directly to the substation, it could be very expensive for us to modify it to make the connection. Or it may be that we don't have any access routes to the substation to lay new circuits in, and again, that could be a constraint. So if the substation was feeding a dedicated customer and it was embedded within their site, it's very difficult for us to then take third-party connections and plug them in. So that's to give you an indication. In this case, we're saying that we don't have any particular problems extending that substation, so it gets a green. If we were then to click onto the upstream button, then it gives us a little bit more information. And this is trying to tell you about things upstream of the substation that could affect what we can do. So the first one to note here is what we've called NGET statement of works. Okay. When we connect to the network, we are changing the national power flows right across the UK, even for small generation. And it may be that a small generator has no particular impact on that national picture, but clearly as you get bigger, you have a greater impact. So we have to talk to National Grid, who own the national transmission network, and discuss with them the impact of generation on our network, the impact it has on their network. So if a site is particularly sensitive to that, then the amount of generation that can be connected before we need to have that conversation with National Grid will be very low. In this case, we're saying that any generation connecting to this substation that is greater than 1 MVA, we would need to have that conversation with National Grid. And the result of that conversation can go in one of two directions. It can either come back and say, National Grid say, yeah, we've got no problems, carry on and connect them. Or they could say, actually, there are issues and we either need this customer to run with some constraints, or we need to carry out some reinforcement work on the transmission system first. And if they have to carry out reinforcement work, then the customer can become liable for either the cost of some of those works or underwriting the works in case they change their mind, and then National Grid has abortive works. So it can be a particularly expensive issue with statement of works, but we never know until we've asked the question. So the thing to take away from that is if it's read for statement of works, we're not saying you can't connect, but there may be a delay in finding out whether or not there's an issue and you can connect without further constraints or costs. So the next tab, voltage constraint issues. This is talking about the voltage now on the upstream network, so on the 33 kV or 66 kV network in this case. It may be that the 11 kV network is separately constrained from the primary system network on the 66 kV. So this is telling you whether there's a problem. In this case, it's saying there are no voltage problems on the upstream network. We know we've got a bit of a voltage issue on the 11 kV network, but if you were to connect a little bit further up on the 66 kV side of this substation, we wouldn't have that same constraint. The next one then is talking about the actual 66 kV circuit and saying how much capacity is there in that circuit and the upstream network that we can accommodate. And in this case, it's saying it's about 12.5 MVA. And so it's also telling you that if you want to connect at 11 kV, you can only connect up to 12.5 MVA because the upstream network can't take any more. If the 11 kV network had a tighter constraint on it, then the number that's green would be lower. So here we've got three boxes all saying 12.5 MVA approximately. Those numbers could be different, but the amount that you can connect, the potential will always be the lower number. So there's two boxes to look at there. Now, there are two buttons at the bottom of this little pop-up window. Okay, the button on the left, View Details, will allow you to have a look at a little bit more data and to see the same data again. And that is actually, once you've clicked on a substation, that data appears at the bottom of the window. So you can either scroll down to see that information, or you can just click on it for more details. And then the right-hand button is our Quick Estimator Calculator. And this is a new feature that's only been added in the last week or so. And that takes a link to a quick cost estimator that I will talk about a little bit more later on. So if you were to scroll down, you're going to see the same information that you've seen before. You're going to see that again. But you're also going to see some additional information that will tell you about the amount of existing generation that's connected to that network. And it will also tell you about the amount of generation that's been quoted onto that substation. So those customers haven't accepted their offers yet, but the offers are out there. And that's just to help you understand. If there was only 1 or 2 MVA left on a substation and you can see that we've quoted a few MVA, then that would help you to weigh up whether you progress through to asking for a formal inquiry, or whether you think, well, actually, it's a bit busy around there. Lots of other people have already got their quotes. If it's really expensive, they're not going to accept, and if it's really cheap, they probably are. So you can take a view on whether you look further at those sites or not. So you've got a little bit of information there to help you understand on a particular site how busy we are to some extent. But there is other information that isn't directly linked with the heat maps, but we have a contracted capacity register, and this is something else that customers have been asking us to do. So this has all our contracted generation summated by its particular substation. So whether it's a grid supply point, the 132 kV substations, BSP, the 66 and 33s, or the primaries where we transform down to 11 kV. It's filtered by the type of generation, so there isn't a line in here for every generator that's contracted with us. They'll be summated together, but they are summated by type. So if you had 2 or 3 wind generators connected onto a particular substation, they would be put together in a group. So we're trying to maintain customer confidentiality in terms of overall agreements, but at the same time we're trying to share as much as we can with other customers so they can get a view on, again, how busy a substation is and what the potential is for connecting more. This particular contracted capacity register does not include our quoted customers that haven't accepted their schemes yet. So that information you do need to get from the heat maps. I've given you a link there again to the contracted capacity register, but if you put contracted capacity register MPG into Google, it will pop straight up there at the top of the list. So I'm just going to hand over to Matt now for a second, and Matt's going to just explain to you how we go around updating the heat maps.
Hi there, I'm Matt, and I'm in at the nuts and bolts end of the heat maps. I perform the updates every month that drive the data that you see. So we broadly split the data into 2 categories. We've got standing data, which we refresh annually on average, not all at once, but as it happens we put it in. So that's a minimum and maximum demands, the assets at a site, details like that. And then every month we include quotations, we include contracted capacity, so an accepted scheme, and we also move any connected schemes from their accepted to connected status. So you can get a month-by-month view of how the network's changing and where the interest is. So all this data gets pulled together to calculate the headroom for new generation and to an extent demand at substations. And we try and publish the updates by about mid-month.
Okay, thanks for that, Matt. So we're getting close to wrap up on the presentation, but before I wrap up, I just want to mention again the quick cost calculator, and I will just show you in a second what it looks like when you go through. As I mentioned, it's a new feature. We've only released this last week, so it is brand new, and we'll be interested in feedback from people about how useful they find it and whether it does what they need. It provides estimated costs for 11 kV connections. So the first thing to say is this isn't designed for large scale generation that could be connecting into our 33 kV and 66 kV sites. The generation typically up to about 8 MVA the estimator is suitable for. It is assuming that there are no local issues, so it's not intelligent enough to say, oh, you're at this substation, so I know there are problems there and I need to add additional costs in it. It's really what I would call the basic cost of the connection, assuming no extra works are required. If your connection size is less than 1 megawatt, then it assumes that you are going to be able to connect into a passing 11 kV circuit. Now, those 11 kV circuits aren't on the heat maps, as I've explained, but if you're aware of high voltage overhead lines in the vicinity of your project, the majority of the overhead lines that you see are 11,000 volt or 20,000 volt circuits. So that's the sort of circuit we're talking about here. Not the big tower lines, the ones on the wood poles. If you're between 1 and 8 megawatts, then the estimator assumes that you will need a brand new circuit all the way from your site to one of our primary substations, which are the substations on the maps that you've seen. So before you go into this tool, you need to know how far you are away from the substation or from your local circuit so that you can enter that value into the calculator. So if you were to Google it and go through, there's a disclaimer at the beginning, but once you've been through the disclaimer, you will come up with a screen like this where you can choose the type of generation you're planning to connect. You can choose your size. So are you less than 190 kilowatts? Are you less than a megawatt or less than 8 megawatts? And you need to say how far it is from you to our network. Now, I suggest that the best way to do that is to go for a drive in Google Maps, because the route that we're most likely to look at first is one that you can actually go down the road rather than across fields if you're in the countryside. So if you go onto Google Maps and choose directions, but make sure you choose the shortest route rather than the quickest route, because there may be back roads that are good for cable routes but not great for driving on. So you put in the distance and give it a clue about whether you've got any roads to cross, minor roads, and it adds in some factor for that, and we'll come up with an indicative price. And if you think that's worth pursuing further, then it gives you a link to go through the normal formal application process. The only other thing I want to mention very quickly is our long-term development statement, and that has geographic plans in that show you where our EHV circuits are. That's our 33 kV, 66 kV and 132 kV circuits are. That information isn't on the heat map overlay, but it is on some maps within the long-term development statement. And I understand now that those maps can be downloaded in a shapefile format so that you can import those into your own GIS systems. So that sort of provides the missing bit of overlay that isn't on the heat maps themselves. Okay, so that's about wrap up in terms of formal presentation. We're going to move over now to the questions. If you've got any questions, please pop them on. While we're just having a quick look at the questions, we've got a polling question for you to find out whether what I've just been telling you about has been any use to you. So we'll just take a few seconds to have a look at what questions have come in, and if you could do that poll for us, that would be very helpful. Okay, so we've got we've got a few questions that have come in. So the first one is, does the substation information reflect any applications or just existing schemes? So the data in the substations only reflects contracted generation. So if someone has made a recent application, or if someone's been quoted but they haven't yet accepted that quotation, then the heat map data that shows how much headroom there is does not include those sites, which is why it's important to go and have a look at the bottom of the screen on any particular generator to see how much quoted generation is out there, to give you a feel for whether that headroom might be getting eaten up or not. So I think someone's asked us about large demands as well as generation. So the connected demands feed into and the connected generation feed into our calculated maximum and minimum demands for the previous year, but they obviously take a while to come through. So what we do is, until they've come through in our actual measured demands, we account for them in our contracted figures. So we make an adjustment for the contracted generation that hasn't yet connected. So the numbers will reflect, the amount of headroom should reflect how much capacity is left, excluding, as I mentioned earlier, the quoted jobs. And that applies equally for load and generation. Our data at the moment is much better on quoted generation in terms of allocating it to the correct sites, and our demand sites, although we've got good information on the EHV sites at 11 kV, the demand sites are a little bit trickier sometimes to allocate, but that's a work in progress to improve our demand side data. Someone else has asked us, does this take into account IDNO connections? So an IDNO connection is where a private network operator has taken a connection from our network, and then they distribute power to their own customers beyond us. So they run a private network that connects to ours. So the answer to that is yes, it does, because that private network operator, the IDNO, is obliged to have an agreement with us for any contracted generation that they want to connect into their network. So while we don't see, maybe they've got 4 or 5 generators in their network, we don't see all those 4 or 5 generators, but what we see is an overall position at the interface between us and the IDNO network. So we have a contracted agreement with them. They're not actually allowed to connect additional generation onto a site until they've agreed with us that it's okay and it doesn't affect our network. And if necessary, we've agreed with National Grid that it doesn't affect the transmission network. So that's covered off. So yes, and the question that goes on with that is, are they obliged, the IDNOs, to tell us when they also install generation? They're not just obliged to tell us, they're obliged to apply and ask us. Okay, so just like any other customer, they could incur reinforcement works or additional connection works that would have to be funded in the same way as any other customer. LV connections. So if small-scale generation is connecting into a substation, although their contracted capacities aren't reflected in the data in the heat maps, they will slowly reduce the minimum demand if they're generating when our demand is low. So they do erode the available headroom for large-scale generation. And if those small generators are less than 4 kilowatts, so what's referred to as a G83 generator, they're typically the type of solar generation you see on the roofs of houses, then they will erode the headroom. We can't stop them connecting. G83 generation only has to inform us that they're connecting. They don't have to ask. So there is a risk there. But if we have a contracted position with a customer, we obviously honour that contractual position. This is just erosion of headroom for customers who are not yet in contract with us. Okay, so I mentioned about our long-term development statement and how do you get hold of that. So I think I've put a link to the. I think I put a link to that. The GIS data for the EHV circuits is available through that long-term development statement, and there's an email link there that you have to click to ask us for the data. When you click on that link, we send you an automated email back that will give you access. So there's a username and password that will give you access to that shapefile for you to be able to take that data and put it into your systems. So that is LTDS at northernpowergrid.com. If you send an email to there, you will get an automated reply with the necessary details in it. Okay, so we haven't got any more questions now. So if you've got any, just quickly type yes, so that we'll hang on a minute. But otherwise, if no more questions come through in the next 30 seconds or so, then we're going to bring the session to an end. Like I say, if you think of anything else in the next hour or so, then we will be available via Twitter, or you can direct mail Emma, which is ICE at northernpowergrid.com, and we'll be available for the next hour or so, till about 1:30. Okay, so no more questions have come through, so I'll say thank you very much for everyone. Oh, hang on. All right. Do we have to pay for the shapefile? No, it's free. Okay, so you'll get a login and password as soon as you send an email to that LTDS at northernpowergrid.com. Okay, yeah, I'm going to wrap it up there. Thank you very much for listening. I hope it's been a help for you. I hope, please, that you filled in our polls that just help us to understand whether it's been of any use to you, this. And as I say, if you do think of anything else, please do get in contact and we'll try our best to help you. Thanks very much and goodbye.